Hello friends, let's continue with our series. In the current lecture, we will be learning about a new data structures problem, which is linked list, right? As you are already aware with the linked list, I'll just start with a brief introduction and then we'll start our program. So, linked list is simply a data structure in which you have the blocks of memory that are connected to each other via pointers, the references, and these blocks, all of the blocks contain the data and the pointer that is pointing towards the next block. These are scattered throughout the memory and only connected via the pointers. So the first block is connected to the next via pointer, and the second is connected to the third via pointer, and so on. Let's begin our program where we will be building some nodes, making a connection, and also at the end printing all of them. Alright, let's begin. So we have our public class here, and within this we will be having our static class node, which is simply the node class, and we are going to be seeing this in a lot of variants of programming websites, TSA questions. So it's just a default code that we have for our nodes in the linked list. Most of the times they are previously mentioned into the websites itself or the problems itself, so you don't have to be really concerned about this, but it's always good to know how these things work. So we are done with our node class, and now we can actually begin. So at this point we have created our class main, which is our public class. Then we have created our node class, which is the basic class for the nodes of the linked list that we have. We have initialized the data, we have initialized node next, right? And after this we have our node class, and in that we have intent data. So for this, here is the usage of this keyword. If you are not familiar, you can go on to the Java tutorial and look for this keyword, but I hope you are already familiar with this if you are starting your DSA problems. So this basically assigns the data of the value to this data, and this dot next, this basically assigns the next towards the null, right, in your node. In a single node the data will represent the data and the next will represent the null, meaning there is no further linking or there is no further pointing towards any other nodes, right? And that's for a single node. So after this you have your public static void main, default format or default boiler code. Then you have the node first, which is defined as a new node with value 10, node second with value 20, and node third with value 30. So that's how you have initialized them for now. Remember, these are not yet connected to each other. We still have to connect them one by one. So we will go on and connect them, or basically create references or pointers so that they can point to each other and are connected to one another, right? So first dot next, meaning the next node after the first node will be second, and we have second dot next equal to third, and finally we're gonna print them. Oh, it's first. So while current not equals null, looks good. Let's try to submit it. And it works. So basically once you have defined the connection between them by setting your references or your pointers, you will then go on here. Your node current is initialized with the first node is your current node, right? Since you want to be printing these nodes or you want to printing the value of these nodes, so your first node will be your current node where you will be, let's just say you will be standing, right? So while your current is not equals null, so as long as your current is not having a null value, your current is not empty, which would also mean it does not exist. So while current does not equals null, we'll go on to the while loop, system.out.println, which is a print command, and we will be printing current.data plus space. This will simply take the data of your current node and print it, right? Whatever the data might be in your node, it will be taking that data, right? And it will be printing it. Once that is done, the current becomes current.next. So whatever your current was, which was initially first, so whatever your current was, it will be becoming the next of the current. So for this node dot first, what is the next? For node dot first or node first, the next is second. So your current will now become second. It was initially first, after that it will become second. So while current not equals to null, while second not equals to null, and hence it will be on the second node, checking if it is null or not. If it's not null, simply print it out, right? print out the value of that node, and then move on to the next node. Keep on repeating it until you find a node where current is equal to null, right? Once you find a current which is equal to null, you stop. So basically you are only running as long as current is not null. Once you find a block or a node where current is null, you stop. That's when you know you have reached the last node and you cannot proceed any further without values or references, right? And let me just remove these extra lines. So there we go, you can see it has been printed in the same line, and with this it is easy to represent some links, right? 10 is pointing towards 2, 10 is pointing towards 20, 20 is pointing towards 30, and so on. This is how linked list and their connections with each other work, and this was an example of singly linked list. We will be getting into more kinds of linked list, like the doubly linked list, the circular linked list, and so on. And for now, that was it for this video. I hope you are able to understand, and thank you for watching.